Hello again, YouTubers. What's going on out there in the world of people? Big discovery here. Huge discovery. You guys been following my work. You know where we're at. Excuse me. It's time we started picking apart all these leftover mysteries that nobody really has been paying attention to. Solved. Why the sun has a solar minimum. Well, hot dog diggity dog. Let's go find out why that's happening. It's pretty simple, but it's complicated in the same sentence here. The planets Jupiter and Earth is the cause of the sun's solar minimum. As usual, it's common sense. Jupiter has an approximate 11-year orbit, and guess what? So does the sun have an approximate 11-year cycle. And it's got an 11-year corkscrew orbit too, unbeknownst to the many people out there, which is controlled by Jupiter. Okay, the cause of the sun's solar minimum is planet Jupiter and Earth. I made this video last night. I was beat. It was like 1 o'clock in the morning. I should know better. Not that the brain's working any better right now, but anyways, I didn't drive home a few points, because I understand it and I forget that other people are not where I'm at. So it's not that I forget. I just, it just skips my mind or whatever. But anyways, I'm going to drill down into all the mechanics so everybody knows what I'm talking about. All right. Right here's a great GIF. And let me shut this light off here so we can see this a little bit better. This is, believe it or not, Jupiter and our sun. Jupiter is such a massive gas giant, it actually alters the orbit of the sun in a corkscrew trajectory around the center of the Milky Way galaxy. Just amazing. So I'm going to just get right into it. All right, it's so big. This is like, your mama is so big. No, just kidding. Here's the sun, Jupiter, the barycenter. The barycenter is kind of like the, the gravitational torque on a mass. And Jupiter's such a large gravitational torque on the sun, the barycenter is literally off the sun by 7 degrees of what, or 7%, I should say, of what the diameter of the sun is, which is absolutely incredible. We're talking about a huge amount of energy, people. All right, so this is where it would be if this Jupiter wasn't in the game plan, in orbit around the sun, and this is where it's at. Now it flexes back and forth during its corkscrew orbit like this, So anyways, we're just to give you a little idea, a little reference point, the Earth-Moon system, the barycenter on the Earth is about a quarter of the Earth pulled from just the Moon, which is pretty significant, even though it's not off the Earth, but it's actually a pretty good sizable torque, gravitational attraction. And the barycenter is located near the Earth, but not at the center line. Now, Shaughnessy's law of gravity added on to the barycenter, and in effect, the barycenter is the center of the gravitational field, and when the Moon pulls it off towards the gravitational field towards the Moon, gets pulled by the gravitational attraction, it actually lowers the gravitational field on the opposite side of the planet, and that's why you get high tide with the moonless side of the planet. That's my contribution to the laws of gravity. All right, or the understanding of gravity. Jupiter passed its aphelion, its farthest point from the sun in its orbit, on February 16, 2017. Okay, it's like for people that can count back, that was about almost a year and 16 February. Yeah, you go it's about a year and 7 or 8 months. So it's going to reach its penphelion, its closest point at or on January 20th, 2023. So Jupiter is getting closer to the sun each day. And what is Earth doing? Okay, well, we know what Earth's doing. It's just spinning around. I just grabbed this. This is just some little bullets for you, so you can pay attention, and just follow along when I'm going to drive home pretty soon. Another artist's conception of Jupiter Earth at opposition when Earth passes between the Sun and Jupiter. Bottom line, you'd think Jupiter would be closest on Earth. That has nothing to do with what I'm talking about. All right, so this is what we're talking about. This alignment, okay? Jupiter, Earth, and the Sun. We're talking about, sticking a yarn needle right straight to two. They're in perfect straight alignment with each other. This happened in May 8th, 2018, and ironically, that's when the solar minimum started, about 3 months ago. And that being said, when the solar minimum starts, there's no sunspots. Okay, they just disappear, and the sun goes into like just a perfect, calm, relaxed form of fission, nuclear fission. Okay, without the disturbances. We're going to get into why that happens. If we gotta keep the clock rolling, I gotta speed up. Keep on moving here. All right. This is just another GIF. Kind of gives you an idea of the size differences on some of these heavenly bodies that are in play here. There's the sun. Okay. There's Jupiter. That's how many Jupiters go across the sun. How many Earths go across Jupiter. So on and so forth. Just to give you a little reference on the sizes. And this is your particular sun corona mass ejection that happens after the solar minimum, generally a few times a year, a couple times, a year we get corona mass ejections. Luckily, we haven't had a huge, massive one with a direct strike. Here's the gas giant Jupiter right now. And this is a topographical view of your solar system. Now, that all being said, this is Jupiter right here, and it gets in line with the sizes are rather. Actually, Jupiter's up here, down here rather. Here's the Earth, and that's the alignment we're going to be looking into. This is the trajectory of the sun through the universe, around the galactic center of the Milky Way galactic center. But that all being said, it's not perfectly correct because the sun itself actually has a corkscrew trajectory. There used to be a GIF on the internet. I don't know where it went, but all things being said, that's pretty close to what's going on. Here's another interpretation of what's going on out there in the solar system. Now we're going to drive home the alignments, what actually triggers the solar minimum. And you just got to get a visual, get up to speed on what's going on. There's the sun's going this direction, and the planets follow on the lower third of the sun's equator. So a lot of these, what do you call it? Well, a lot of these elliptic orbits around the sun, they're not all flat. They don't all meet each other. This is where I blew the video yesterday. I didn't drive this home well enough. And so the point is, the moon and where's Jupiter? The moon and Jupiter are at different. The moon and Jupiter. The moon and Earth are at different planes. Now, even though the Earth goes around the sun every year, it passes Jupiter 11 times, but it only reaches that direct alignment once, okay? Once, and that's right after the aphelion of the furthest reach of Jupiter's elliptical orbit from the sun. A couple of months after that, or a year after that, that's when the Earth comes in and the straight alignment happens between Jupiter, Earth, and Sun, and that's what shuts down the sunspots, which are giant magnetic torque storms on the surface of the sun. There's a little bit more information here, and that's the big discovery. Going back, that's the big discovery, is that everybody's been thinking that this alignment happens every year between Jupiter and Earth as it passes it. No, it doesn't. It is not 100% straight in deadline, right straight through with the old proverbial yarn needle. There's a little bit of what we call coronal zone, radial, and side view, not to scale, but it kind of gives you an idea of how we go up and down in our elliptic orbits associated with the sun. Although Jupiter's not in there, but all the other planets have they go up and pass on the elliptic plane around the sun. This is a GIF and it should work. It's not the Jupiter, but it'll give you a visual of what I'm trying to drive home here. Now, it looks like the camera's actually doing pretty good. I gotta watch my hands because I throw the camera out of alignment. So this planet, Mercury, is gonna end up straight in front of the sun. Now, this is what I'm talking about. Just imagine this is Jupiter and Earth. They're directly, bam, right in line with the sun. Okay. And here's another cross pattern. This is the moon, but you see the two elliptics, Jupiter and Earth's elliptic cross in the crosshair at the beginning of the solar minimum back in May 2018, and that's when the beginning of the solar minimum started, and it just landed right in there. And right here is this is the elliptic orbit of Jupiter during its 11-year travel around the solar system. And you can see it's at different levels, just to give you a visual. And lo and behold, the classic understanding of Jupiter was Zeus, the father god. Okay, so they named these planets appropriately because he is the strength in the solar system, besides the sun. I mean, he is the gravitational torque. He's the gravitational strength. There's a good rotational GIF of Jupiter, and that's kind of what's going on here. All right, this is the proverbial yarn needle going through these 2-3 heavenly bodies that trigger the solar minimum. Okay, Jupiter lines up in this alignment, like I said, perfectly straight in this alignment once every 11 years. Unbeknownst to the astrophysics community, nobody's taking a look at this except yours truly. This is what shuts the sun down. Now, what's going on? Why does the sun shut down with this anomaly? It's just the Earth. Little old tiny Earth is nothing compared to Jupiter. It's like 10 times wider. Well, what do we have around the Earth? The Van Allen belt. Okay, the Van Allen belt, the magnetic field around planet Earth, acts as a gravitational buffer, a filter that softens the gravitational tug between Jupiter and the sun. All right, that's what causes the solar minimum. And the fact that the corkscrew orbit of the sun is at its at its furthest distance away from Jupiter also, because it's in a corkscrew alignment also. So that all being said, you got 4 things going on here, right? You have Jupiter in total alignment with the sun and the Earth. You have the sun in its furthest orbit away from Jupiter, and you have Jupiter in its furthest position away from about a year out from its furthest trajectory from the sun. Still, that being said, it's still far away. And then you have the Earth's magnetic field acting like a gravitational filter softening the pull on the sun, and therefore that removes the gravitational vortexes and the magnetic vortexes that create the disturbances, the coronal mass ejections, the huge magnetic storms that happen on the sun. There's the sun right here, and you know, this, for the most part, this isn't, this might have been a year, this was the last solar minimum. You can see it's peaking, and then it drops down summertime, you know, August, to nothing, just to barely nothing, and out it goes. So that's what it's all about. That's what controls the solar minimum. I think I answered all the questions. So, I mean, all the points that I wanted to, not answer, but spoke of all the points I wanted to. So to wrap it up, okay, we got Jupiter, all right, and the straight alignment between Earth and the Sun. Most of the times, the other 10 passes that Jupiter does around the Earth, or the Earth does in front of Jupiter, is above or below it. It's not in straight, direct alignment with the Sun, except for once every 11 years. And that, my friends, is what shuts down the Sun. It's the gravitational filtering mechanism that the Earth and the Van Allen belts put up in front of the gravitational field tugging on the Sun. So in essence, it kind of just smooths out the Sun's, you know, where is the Sun? Oh, black old Sun, where have you gone? So yeah, so yeah, there it is. So that's what's going on. It just calms down that whole face of the Sun that points towards the Earth and Jupiter. All right, you heard it here first. Shoot me up some questions. Thanks for the guy that called me out on that, because he said you lost me on that one. It's like the Earth, you know, passes Jupiter 11 times. So I don't understand why doesn't it happen. Why don't we have a solar minimum every year when we go by Jupiter? Well, Jupiter's in a different part, but again, it's at a different plane. Okay, it's not directly on. So you need to be directly on, straight on, bullseye. You know, the yarn needle, laser beam, you know, spear, shish kebab spear, going through all three of these heavenly bodies to shut down the gravitational pollution that's actually, you know, causing the Sun a lot of stress. So anyways, that's about it. You heard it here first, YouTube University, and got a couple other, I'm doing another video that I'm putting out. My name is John Shaughnessy. This is copyrighted stuff with the registered number, so if you want to use it, go ahead, you know, as long as it's not for profit, but do drop my name, okay? I don't want you, especially you guys in college, liberating, some of you guys are liberating people's original ideas and turning in your papers for your final thesis. Better watch out. Not that would happen in the world, just saying. All right, here's my book, Pyramid Gravity Force. There is something about the moon. I nailed this graph dead to wrong, dead to right here. Just didn't get any perfect in that. That shows exactly, you know, the gravitational flow between these two heavenly bodies. Check my other videos out. Going to be speaking at the Second International Scientific Global Conference in Chicago, September 2023. Going to be talking about the healing potentials of the pyramids and when to go into a pyramid. Yeah, you just don't go into a pyramid just because you showed up on time. There's actually a science behind getting into these things and accentuating your you know, chakras, the healing chakras. Okay, well, so we'll get into some of that stuff, and I'll talk about my other information that I'm bringing into the world. All right, couldn't do it without you guys, ladies, and again, shoot me an email if you got anything you know, want me to do. You got any questions or anything like that? Keep them coming. Peace out.